Hello, I'm Cynthia Rabinowitz. I am a soil and wetland scientist. Hi, I am going to talk to you for a little while about wetlands. And I would like to point out that 2022 is the 50th anniversary of the creation of the Connecticut Inland Wetlands and Watercourses Act. So that is a big milestone. We've been protecting wetlands in Connecticut for 50 years. So in addition to being a soil and wetland scientist, I'm also somebody who really loves to read, and I like poetry and literature of all kinds. And I particularly wanted to share a little bit of a poem here, part of a poem by Gerard Manley Hopkins that I like very much. And I'll just read it out to you. What would the world be once bereft of wet and of wildness? Let them be left, wildness and wet. Long live the weeds and the wildness yet. I think that's really beautiful. And I think of that often when I'm working in wetlands, how much they mean to me, how wild they are, and generally separate and different from other places that you can see. Also, I would like to mention that wetlands function as the Earth's kidneys. Many people do realize that trees are like the lungs of the Earth, helping to clean our air, but many people don't know much about wetlands and certainly don't realize the role that wetlands play in helping to keep our water clean. That is a very important function as well. So in my readings about wetlands, I've often come across the terms that we see in the column on the left side under negative terminology. These are some words that I've seen in novels mainly and plays about wetlands, and they are given these negative descriptions. They can be thought of as malicious or smelly, pestilential. You know, people used to think that diseases came from swamps, and bogs have a bad reputation because of, people getting stuck in them. So there's a lot of negative thoughts about wetlands, and that has led to the destruction of wetlands, not only in this country, but all around the world. And by filling and draining, we've done a lot of that in this country. And so it was very important when Connecticut enacted its Inland Wetland and Watercourses Act to help save our remaining wetlands and preserve them. On the positive side, apart from the scientific functions and values that wetlands provide, which I'll be talking about in another segment of this course, there are other indeterminate positive aspects to wetlands. So I just came up with a few words here that I feel are good things about wetlands and that make me drawn to them. So the water itself is, of course, life-giving and very important. Wetlands can feel like sanctuaries. In some cultures, wetlands are considered sacred. They're definitely very calming places, and they're fascinating and interesting. And I highly recommend that people get to know the wetlands that are around their neighborhoods and go visit some special wetlands like the white spruce bog at Mohawk State Park. That's a really good one to go visit. Okay, so we'll talk a little bit about the more scientific aspects of wetlands. Wetlands are found at the interface of terrestrial and aquatic systems. So that means between dry land and open water. Here's a good diagram that shows how wetlands in the center column here are situated between a dry hillside on the left and open water on the right. The arrows that we that we see are showing the direction of water flow. So we have the arrows pointing up and down in the center column in the wetland area. So that would be water from precipitation and water moving down into the soil below the wetland surface itself. In the column on the left, we have an upland area, which are generally considered to be dry. So that would be the terrestrial system. And on the right, we see the deep water aquatic system, where nutrients and biological species are moving. They can move actually back and forth from the aquatic system into the wetland area. From the terrestrial system, nutrients and biological species generally move from the dry area into the wetland. One thing that's not shown on this diagram that I would like you to know about is that in addition to water moving over the surface of the ground, so flowing downhill from the terrestrial system into the wetland, water can also penetrate the surface of the soil in sloping areas, depending on the degree of slope. But the water that penetrates the soil will move downhill, but it will move laterally underneath the soil surface. And because of the change in the slope of the land surface, we can see quite clearly here, there's a slope change from the terrestrial system into the wetland area, which is depressed, more of a concave shape to the land surface there, whereas the hill is slightly more convex. So where we have these concave areas, the water that's underneath the soil surface moving laterally downhill will pop out at the grade change and enter into the open water, if there is open water, in the wetland. So wetlands are part of watersheds, just like dry land is. And here we see the lime kiln brook watershed, which is a watershed in southeast Bethel. And this watershed is depicted by the outline area in red. The brook itself is shown in a dark blue, and then there are some lighter blue-gray tributaries entering into the brook itself. And then we go to the next slide, which shows the Still River watershed depicted in purple. And we can still see the outline in red of the Lime Kiln Brook. And that's nestled in the southeast of this Still River watershed. And we can see that it's a much smaller watershed compared to the Still River. And one more time, we go to the major watershed of the Housatonic River, which extends up into Massachusetts and over into New York State and eventually drains into Long Island Sound. And we can still see here the area outlined in red, which is Lime Kiln, and in purple, the Still River. And we can see how those are part of the Housatonic River watershed, which comprises many, many smaller watersheds within its boundaries. So the key thing that I wanted to have you take away from this is the concept that every drop of water that falls on our land surface enters a watershed. Every spot on Earth is part of a watershed. So here we had the Lime Kiln, a small watershed. All the streams and rivers and ponds and lakes and stormwater runoff and water that goes on the ground from washing our cars or watering our lawns or that flows off of impervious surfaces will enter the rivers of that particular watershed, which then flow into the next sized watershed, and so on and so forth, until the large main stem watershed reaches open ocean, in this case, Long Island Sound, which is part of the Atlantic Ocean. So the key thing here is that everything that we do on the land surface that involves water or chemically made substances, if they're liquid, they're going to enter into our hydrological cycle and have an effect on our water quality. So wetlands being found between dry land and open water play a huge role in helping to clean the water that is moving through our environment. In this particular picture, we see an inland wetland with hydrophytes. Hydrophytes are plants that can tolerate wet conditions. In this particular example, we're looking at Joe Pyeweed. And this wetland is adjacent to a large pond, which we can see in the background. If you look carefully, it's a little misty, but you can see that there's some open water there behind this vegetated wetland. Now, although in general, wetlands are found between terrestrial and aquatic landscapes, sometimes there are isolated wetland pockets, and that is particularly true in the Northeast, where we have a glaciated landscape that has created all kinds of variation in the way our land looks. We have the sloping convex areas, we have little depressions on the hillsides, and we have valleys and high ridges and all sorts of things in between, making it a very interesting and attractive place to live. It also creates plenty of opportunity for water to be slowed down and remain held in depressional systems in the landscape. So these little pockets here are not technically between terrestrial and aquatic, at least at the surface level, but remember that water does move under the soil surface and eventually will reach the aquatic ecosystems. Some isolated pockets of wetlands are considered to be vernal pools. You may have heard that term. Vernal is another word for springtime. So these types of wetlands have their highest water levels in the spring, and they usually dry down completely by midsummer or have just a very small amount of water. This particular pocket wetland may or may not be a vernal pool. Just because it's an isolated pocket that's holding water does not make it a vernal pool. The definition of a vernal pool includes the fact that it would also be a habitat for certain animal species that are obligate for aquatic settings. So there has to be open water, even if it's just a little bit. This could be technically a vernal pool if we found the obligate species breeding in it, and that would usually be during March or early April in Connecticut, depending on the season and the temperatures. So not all isolated wetlands do have the right combination of habitat and amount of water and the drying down that is necessary later in the season, because these obligate species have a very particular breeding cycle, and their reliance on the water in the spring is not necessarily carried through their whole lifestyle. So the Connecticut shoreline is well known for its salt marsh hay, coastal wetlands and other types of coastal wetlands, many of which unfortunately have been destroyed. A lot of the Connecticut coastline is developed, but we do still have some beautiful areas. There's some lovely state parks along the Connecticut coast where you can see these types of coastal wetlands. Lastly, I just want to pull together using this diagram what we've talked about. So to create a wetland, we need the right setting. We need the geomorphology. So on the left-hand side of this diagram, we can see that word geomorphology, which relates to the shape of the landscape. So the geology and the shape of the landscape is very important. And on the right-hand side, we see climate. The climate is also very important because we need the climate to provide the rainfall, which provides the hydrology necessary to contribute the water to make a wetland. If we don't have the hydrology, we can't have a wetland. So hydrology is really the dominant factor here. We need a certain type of soil chemistry going on with fluctuating water tables, and we need the biota, the vegetation, the animals, and the microorganisms to create the biological characteristics that we find in wetlands. But the most important thing from this diagram is the hydrology and the shape of the landscape. Without those two things, there would be no opportunity to create the habitat for the biota. Okay, well, thank you very much.